All right, so this section 4.5 and 4.6 both have two very important things. They're called the irrational conjugate theorem and the complex conjugate theorem. So irrational conjugate theorem, and I'll write those down. And I'm just going to put it right here. So one of them is the irrational conjugate theorem, and one of the is the complex conjugate theorem. I don't know why I spaced that out so much, but whatever. So one of them is the irrational and one of them is the complex. Irrational means that a number never ever stops. So it's something like this, where you have like the square root of 5. So the square root of 5 is irrational because when you type the square root of 5 in your calculator, you get a decimal that never ever stops. If you said something like the square root of 9, the square root of 9 is not necessarily irrational, so it's not a big deal because we know that the square root of 9 is plus or minus 3, right? Now that is the reason that these types of theorems exist. Because if I were to ask you to solve any sort of problem, no matter what, if I ask you to solve any sort of problem where you get like x squared equals 5, every one of you knows that you would take the square root of both sides, and then what we would do is we would say x equals plus or minus the square root of 5. So this is the reason that that conjugate theorem exists. Because what I can technically do to you now is I can technically say that I could say write an equation that has a solution of x equals the square root of 5. So the question would say write an equation that has x equals square root of 5 as one of the answers. Now the thing is, it is impossible for me to actually get a solution where only x equals the square root of 5 is a solution. We would also have to say that x equals negative square root of 5 is a solution for the reason that this thing exists, right? Whenever you take the square root of something, you have to introduce a positive and a negative. Now, if the question gives you this, they're only giving you the positive. They are relying on you to remember or understand that this would also have to be a solution to something. So the complex conjugate theorem and the irrational conjugate theorem are dealing with square roots in both cases. Because technically with this side, with complex, is if I have something like 2 plus 3i, this literally means 2 plus 3 times the square root of negative 1. Now that being said, if I do any sort of problem at all ever where I introduce a square root, I also have to introduce the negative square root. Because if I take the square root of something, both the positive and the negative are going to be answers to this. So that means with the complex conjugate theorem, if I am told that 2 plus 3i is a solution, I have to know that 2 minus 3i is also going to be a solution because I have to have a negative square root as well. So in this one, I have a positive square root, and down here I have a negative square root. Up here I have a positive square root, down here I have a negative square root. So I'm going to go through an answer or a question with you, so that way we can kind of see what's going on. So I'm going to write down kind of a long set of directions because this is the set of directions that you're going to have every single time. But the set of directions will say something along the lines of write a polynomial of least degree with a coefficient of 1 and zeros of x equals 3 and x equals 2 plus the square root of 5. Now, what you have to think about here, the idea that you're asked to do, or the idea that you're being asked is, here are the answers, come up with the question that would have produced those answers. So if you remember what we did yesterday we solved, right? I gave you a question and I said, solve this. And then you would have been able to solve and find x equals, x equals, x equals. Now that being said, this question is doing the exact opposite, where it's saying, here are the x equals. What is a question that would have produced the answers that you see here? So that being said, you have to think about this in a kind of a critical way. You have to think, are there any of these solutions that there are hidden and they're not telling us? Because there could always be more solutions, right? This is saying at a minimum, Find a polynomial that has a least degree and it has these zeros. Now, it could have more zeros, who knows? But we have to have at least x equals 3 and at least x equals 2 plus the square root of 5. But remember, if I'm solving a question and I take the square root of something, if you take the square root of something, then you have to understand that there has to be a positive and a negative square radical. Because if you take the square root, there has to be a positive answer and a negative answer. So right here, we have the positive answer. So what they're hiding from you is they're basically saying, here is the answers. You have to know that x equals 2 minus the square root of 5 is also going to be a solution. So anytime there's a radical, you have to put an opposite sign in front of that radical in order for it to actually exist. Because now when I combine these together, if I take the square root of something, whenever I take the square root of something, I'm going to have a positive and a negative, which is exactly what we need to see. So what we're going to do is we're going to work backwards now. Okay. Remember the steps that we did with all of these solve questions, the steps that you do, the first thing you do is you factor, then you set equal to 0, then you solve. Now we're kind of working backwards. So with these, where we're writing an equation, what you're really asking now is you're given the solved form. Then you are asked to go backwards and set it equal to 0. Then you are asked to put it into its factored form. So that's what you're being asked to do. We're being asked to work backwards. Right now we have the solved form. Then what we want to do is we want to set it equal to 0 on one side. Then we want to rewrite it in its factored form. So that's what I'm going to do here. I'm going to go through the steps, and then I'm going to give you one of the complex ones so that you can try it on your own. So each of these, I'm going to have x equals 3. I'm going to have x equals 2 plus the square root of 5, and I'm going to have x equals 2 minus the square root of 5. Each of these, I want it to say equals 0 on the right side. So I'm going to subtract 3 from both sides, so I'm going to get x minus 3 equals 0. On this one, I'm going to subtract 2, and I'm going to subtract the square root of 5. So I'm going to get x minus 2 minus the square root of 5 equals 0. This one, I'm going to subtract 2, and I'm going to add the square root of 5. So I'm going to get x minus 2 plus the square root of 5 equals 0. These things right here are called the factors. These are the factors. So these things right here are what are going to be put in parentheses, and they're going to be put next to each other. So that way we can come up with our equation. So that being said, I'm going to take x minus 3. I'm going to take x minus 2 minus the square root of 5. And then I'm going to take x minus 2 plus the square root of 5. And then that's going to be equal to 0. Okay. So now what we're going to do is we are going to multiply these out. Now this is really where 4.4, I think, 4.2, whatever it was when we talked about multiplying functions out, we are going to multiply our functions out. Now you can do this however you want. You can do it in any mode, any method, anything that you want to do. But my big suggestion to you is, instead of multiplying left to right, find the two that are the same or very close to the same and start with those. All right. So I'm going to start with just those right there, and I'm going to multiply those together. So I'm going to leave this x minus 3 on the outside, and then I'm going to multiply this stuff together. So I'm going to do x times x, which is x squared. I'm going to do x times negative 2, which is negative 2x. And I'm going to do x times the positive square root of 5, which is going to give me positive square root of 5. Actually, I'm going to do positive x square root of 5. Then I'm going to do the same exact thing with all of the other terms. And it can be a lot of work, but you should be able to see what's going on. So now I take negative 2 times x, which is negative 2x. Negative 2 times negative 2, which is going to give me positive 4. And then I have negative 2 times positive 5, which is going to give me negative 2 square roots of 5. And then I'm going to do it one last time with the square root of 5. So here I'm going to get negative x times the square root of 5. This one I'm going to get negative 2 square roots, positive 2 square roots of 5. And then this one here, I am going to get square root of 5 times the square root of 5 is 5. So I'm going to get minus 5. And you can see how this is a lot of work and a lot of stuff going on. But the thing that I want you to notice is a majority of the things in here are going to cancel. So like this part right here and this part right here will cancel. And this part right here and this part right here will cancel. So all of the ugly things are going to end up canceling and going away. And I'm going to be left with only my normal terms where I have like x squared, x, 4, and then 5. So this will cancel with this right here. And then this will cancel with this right here. And now I'm just going to combine my two terms again, or all my terms again, into its most common form. So I have x minus 3. Then I only have one x squared up here. So I have x squared. I have a negative 2x and a negative 2x, which is going to make negative 4x. And then I have a positive 4 and a negative 5, which is going to be minus 1. Okay, so then what I'm going to do is I'm going to multiply this out the same way that I did last time. So I'm going to take my form x times x, which is going to give me x cubed, x times negative 4x, which is going to give me negative 4x squared, x times negative 1, which is going to give me negative x. And then I do it again with my second value. So negative, go away. So I have negative 3 times x, which is x squared, which is negative 3x squared. I have negative 3 times negative 4x, which is going to give me a positive 12x. And then I have a negative 3 times negative 1, which is going to give me a positive 3. And now I just combine my like terms. And once I combine my like terms, I'm done. I only have one x to the third term. I have a negative 4x squared and a negative 3x squared, which gives me negative 7x squared, negative x and positive 12, which is going to give me positive 11x, and then plus 3. And this will be my final answer because I have multiplied everything out. And once I have multiplied everything out, I am all set. Any questions that you guys can think of with this?
Yeah, so what would the question look like when we are supposed to do it this method?
These words right here.
And it's going to just be exactly like that, and then
Yep.
we possibles. Okay.
Yep, and then it'll give you your zeros, and then you just work backwards the same way that I did every time.
Okay, and can it be done with more or less like groups of numbers? Or
It can be, yes. So it can be done with anything all the way down to 2 numbers. And it can be done with anything up to, I mean, as many numbers as you want. I wouldn't give you any more than like 3 or maybe 4. Most of the time it's going to end up being 3. So it would be almost identical to this, but it could be done with as many as possible. It's just very rude to make it any more than, 3 or 4.
Yeah.
So let me do one with complex. So what I want you to know with complex is, this is an example. If 2 plus I is a solution, so is 2 minus I. All you're doing is changing the sign in the middle. So if 3 minus 2I is a solution, so is 3 plus 2I. And the same exact thing is true with with radicals. So the same exact thing is true with radicals. So you might say something like 3 minus the square root of 2, which means that you also have to put 3 plus the square root of 2. If you had 3 plus 5 square roots of 6, then you would have to do 3 minus 5 square roots of 6. The only thing I want to mention to you is every once in a while, we are allowed to have, or they might say something like, if 2I is a solution. So if you have 2I as a solution, then you also need to know that negative 2I is a solution. Or if the square root of 7 is a solution, so is negative square root of 7. So they don't all have to be in the form where they have a lot of stuff happening. Sometimes they're going to be in this basic form. And if they're in the basic form, that actually makes your life a little bit easier. So that's saying that you have just negatives instead of having to do the 3 plus 3 minus. Okay. So I'm going to go back and I'm going to rewrite. Actually, I'm just going to use this. And I'm going to give you another question, and I want you to try this question out. Oops. So I'm going to give you another question just like this that I want you to attempt on your own. And I'm going to give it to you in terms of complex conjugates. You may also have questions that have complex conjugates and irrational conjugates, which just means that you have a square root and an I value. But in this case, I'm just going to start with the complex so that way we can make sure that we understand what's going on. So let's say that we have a 0 of 2. So let's say that we have a 0 of 2, and let's say that we have a 0 of like 3 plus I. So I want you guys to attempt this. Write a polynomial the exact same way we did last time, using I instead of the square root, and make sure that you pay attention to the conjugate, okay? So I'm going to pause my recording for a second. So the first thing you have to do is you have to identify that there is a conjugate in here, and that conjugate is this one with I. You do not have to do it with this. There is no issue with solving something that just says 2. You don't ever have to take this. I mean, you don't have to take the square root of something to get 2, right? You don't have to. You do have to take the square root of something to get I. So that means that x equals 3 minus I is also going to be a solution. So working backwards now, I know that I have x equals 2. I know that I have x equals 3 plus I. And I know that I have x equals 3 minus I. Oops. And I want this to equal 0. So since I want this to equal 0, I'm going to move everything over to the other side. So this would be x minus 2 equals 0. This one will be x minus 3 minus I equals 0. And this one will be x minus 3 plus I equals 0. So these are my factors. This is really the most important step to this whole thing because the rest of it's just multiplication. And as long as you know the multiplication, you should be good. So I'm going to go through and write my factors. So my factors are going to be x minus 2, x minus 3 minus I, and then x minus 3 plus I equals 0. Actually, you don't even have to have the minus 0 equals 0 on there. You could just put this because it tells you to write a function, not an equation. An equation doesn't have an equal, or an equation does have an equal sign. A function doesn't have. All right. So here I am going to combine these two first. So I'm going to go through my work of combining these. So I'm going to get x times x, which is x squared, x times negative 3, which is negative 3x, and then x times I, which is going to give me positive xi. I'm going to do the same exact thing with every single one of these terms. So negative 3 times x is negative 3x. Negative 3 times negative 3 will give me positive 9. And then negative 3 times I will give me negative 3i. And then I have my last one. And my last one is going to be negative I times x, which is negative xi. Negative I times negative 3, which is a positive 3i. And it was asked earlier, negative I times positive I is going to give me negative I squared. But negative I squared is the same thing as saying negative negative 1, which is positive 1. So this is going to be a plus 1. Then remember, I have that x minus 2 that was out in the front earlier. So that x minus 2 is still out there. Now I'm going to cancel out everything that can cancel. So I have a positive xi and a negative xi. I have a positive 3i and a negative 3i. Basically, everything with I should cancel. Everything that just has I by itself should cancel. So now this is going to end up being x minus 2 times x squared minus 6x. And then 9 plus 1 is 10. So x squared minus 6x plus 10. And now I'm going to double distribute again with this one. And this one should be a lot easier than the last one because it's just normal. So x times x squared will give me x to the third. X times negative 6 will give me negative 6x squared. X times 10 will give me 10x. And then I have negative 2 times x squared, which is negative 2x squared. Negative 2 times negative 6x, which is positive 12x. Negative 2 times positive 10 is negative 20. And then I combine my like terms here. So I get x to the third minus 8x squared plus 22x minus 20. And this will be my final answer. Any questions you guys can think of? All right, I'm going to stop my recording.